going on, guys? Welcome back to this video. Today we're going to talk about a very hot subject, which is DLL injection. Now this is a continuance of what we have done in the previous videos. So in the previous videos we talked about, if you remember guys, process injection, and we also talked about process hollowing, right? Now DLL injection is used similarly for the same purpose. Why do we use DLL injection? There are two purposes. So in the first one, we look to maintain access to the machine that we have compromised, aka we call that persistence, and we're gonna explain why. The second goal, or not gonna say second goal, the second use of DLL injection is to compromise the machine. So basically we can also compromise the machine by injecting or using malicious DLL. So we can say compromising or machine compromise. Okay, so after we have learned why do we use DLL injection, let's now get to it. So how do we, or what is DLL injection? Okay, so first, guys, we have apps and programs, and we learned that apps and programs use processes, right? Now processes rely also on DLLs, dynamic link libraries. Dynamic link libraries can be used by many processes simultaneously. For example, if I have one process, let's say it is Explorer, and another process, Notepad. Okay, these two processes both can be using the same DLL file. Okay, and that's how applications are loaded faster in Windows. That's one of the reasons why applications are loaded faster in Windows, because Windows allows you to use more than or the same DLL by more than one process. Alright, so what this has to do with DLL injection? Okay, so now that we have learned how DLLs are used by processes, now let's explain why DLL injection is an effective process. So basically, if I could have first access permissions, okay, access permissions over what? Over the DLLs used by a specific process. And if I can learn the name of these DLLs, so what's the next step? Next step is to generate a malicious DLL. Now, a malicious DLL can be generated using MSF Venom. As an example, there are many ways to generate a malicious DLL. So we generate a malicious DLL. Let's say it is evil evil.dll. Okay, now how do we use this, or how do we put that in use? So basically we have to spot a process. Let's say we want to compromise this process, Explorer. So in order to do that, we have to learn all of the DLLs used by the process. So let's say it is using ntdl DLL, and let's say it's using another DLL called driver DLL. So we learned all the DLLs used by the process. Next thing, we have to check our access rights. Do we have access to replace those DLLs or modify them? If yes, what we're gonna do, we're gonna generate this DLL, okay, and then change its name to match one of these DLL's names used by this process. So let's say it is ntdll. So we're gonna change the name to this name, and then we're going to replace the original DLL with the fake one we have just created. What's gonna happen next? We're gonna restart this process, and the next time it starts, it's gonna use our version of the DLL. Now what this DLL does, basically it can start a reverse shell to your machine, so you're gonna get access to the machine. and you can configure to do whatever you want using MSF Venom. Now that's the first method, and that's the easiest method of DLL injection. Now let's talk about another method of achieving DLL injection. This is the method that requires you to have access to the machine, because you want to technically, no, you don't need to get access to the machine, so you can do it even if you don't have access. So in this method, we need to have an access to the machine, at least a limited access, or limited shell. So let's say we have got access now, and we just issued who am I, and we were like any user, like the IIS or the web server user. Okay, so now we want to go through the next method of achieving DLL injection. The first step, we want to list the current processes. Similar to the first method, we want to choose a process to compromise. So again, in the next method or the second method, we list the processes running on the machine. Next, we want to locate the DLLs. Okay, the DLLs used by the machine or used by the process. So this also, the next step also helps in if you want to shift to the first method of creating a DLL that matches one of the DLLs used by the process. Now see, what we want to do, we want to allocate memory size. So memory for what? For the malicious DLL. Now the malicious DLL again can be created using MSF Venom, and you can configure this DLL to do whatever you want. You can configure it to maintain access or to start a reverse shell. So this one can be generated by MSF Venom as an example. Okay, so in the fourth method, or in the fourth step, we want to write evil.dll into what? Into the allocated memory we have just allocated in the previous step. And in the last step, we will want to load and execute the malicious DLL, evil.dll. Okay, now how do we do this, all of this? So here in the first method, we can list the current processes, learn the DLLs by just having access to the machine, and then we can generate the malicious DLL using MSF Venom, and then it's a matter of copy and replace to achieve or to complete the first method. What about the next method? How do you allocate the memory and execute, load and execute, so on and so forth? For that, we have to create a code. So we need a code written in C++. Okay, this code will be compiled. Okay, and after compiling the code, we need to, for example, let's say the code, after we compile the code, it is evil.exe, and then upon the execution, we provide the process PID as an argument in the command line. Now, this executable contains the malicious code or the malicious DLL inside of it. Now that's one scenario. Another scenario, you don't need to include the malicious. Let's say you don't have the code for this DLL. So what you have to do, you have to provide the process PID and evil DLL as another command line argument. So you execute your code, providing the process PID you want to target and the DLL you have just generated. Now we solved the problem of choosing the process and generating the MSF venom. But how do we make sure that this DLL is effectively loaded by the executable? By the process. Here, for example, we have to make sure that the memory allocation is correct. Now, to do that, we have to use API calls. So in your code here, we're gonna use API calls. Let's go over a sample code, and then we demonstrate that in action. Remember, guys, that this is part of this room, abusing Windows internals. Specifically, we're doing task 5. Now, if we head over to the machine, and now let's open the machine. Let's allow copying. All right, so we go to injectors, and in the injectors we have the evil DLL generated for you, and we have the DLL injector. First, let's go over the code. So here in the source, you can find the source code of all of that. I just copied the source code here to be able to have the colors implemented. And as you can see here, guys, there are many API calls used in the code. These API calls are needed to open the process, to create the thread, to allocate the memory for the malicious DLL, so on and so forth. For example, we have this API call create tool help 32 snapshot, and we have process entry, process 32 first. These API calls are necessary for opening the target process that you choose for DLL injection. Here we have the the usage of this tool. As you can see, in the command line, we supply the name of the executable with the process PID and the path to the malicious DLL. Next, we have another API call here. Let's see, open process. So after we provided the PID in the command line, the code will perform this API call to open the targeted process. And then, as you can see, we allocate memory from the targeted process so that when providing the malicious DLL, the allocated memory is ready to be used. And then we write process memory to make sure that the DLL is using the allocated memory. And lastly, here we use create remote thread to load and open the injected DLL. So how this happens, if you go here, and now let's assume that you guys have got access to a machine and you have your DLL injector is ready. So what we're going to do, we're going to navigate to where it is located. Properties, let's make this bigger. And there are. So here we have the malicious DLL. Now you might be asking how to generate a malicious DLL. So we can generate a malicious DLL again, guys, use Metasploit. Let's see if I have an example. So here, guys, you can use any regular malicious, any regular MSF venom command. Just make sure that you select the target operating system correctly, whether you are targeting Linux or Windows. At the end, the extension will be DLL. Okay, just make sure you do that while creating the malicious DLL. Or you can do that, you can look it up online. Generate malicious DLL MSF venom. DLL injection, DLL hijacking. So look at this command. Here we have Windows selected as target platform. At the end, we choose that we want to start a reverse shell, interpreter reverse shell, and the extension will be DLL, similar to any one of these. Okay, so now we have the DLL running, the DLL transferred to the machine, and we have the injector that we compiled earlier, and next we need to select a process to target. So let's open Task Manager, or you can use task list. Okay, if you only have command line access, so assume that you have only command line access, we need to have a stable process that is run by the user we have got access to. So if you type who am I, we are THM attacker, so we need to select a process, okay, that THM attacker is controlling or has access to. Here, if we go to details, we can see that we have many processes. We're going to use Explorer. Again, Explorer can be found from here. Let's see where it is. So we have Explorer process, and as you can see, the PID is 3764. So DLL injector, the PID is 3764, and the DLL that we generated is the evil DLL. Now we're going to execute and see if we will get the flag. So execute. Let's see. So nothing happened. Okay, so instead of providing the PID or the process ID, we're going to supply the name of the process. So let's go back to, or let's use the same here. We don't need to list the processes again. So instead of the process ID, we're going to use its name, Explorer. Let's see if this worked. And this time it worked. So now this is the flag. Now the flag here was executed, of course, by the DLL, right? Now if you configured or generated the DLL to behave in a certain or different, or to give a different output, you're not gonna get the flag. You're gonna get what you configured to the DLL to do. Example, reverse shot. So that was it, guys. Now for the answers of the rest of the tasks. So memory execution alternatives and case study in browser injection and hooking. I don't have labs or in the room, but the questions, you can find the answers for these questions as you can see here. You can find them in my website if you want to have a look of all the answers. So guys, that was it, and see you later.